Okay, good evening, Professor David J. Los Reyes. Okay, my topic for this evening will be a long video format discussion topic, and this is on the study of trigonometry, and we are now on lesson number 9. Okay, let's proceed. The subject matter for this evening will be trigonometry, and this will now be lesson number 9. We are running smooth, okay? The title of the topic will be Variations in trigo function values in sines in each quadrant. So what we will be discussing tonight will be the values, okay, and the sines of the different trigonometric functions. We are actually given 6 trigonometric functions, right? Sine, cosine, tangent, okay, secant, cosecant, and cotangent. So our topic for tonight will be on how to determine the values. How does the value of each sine of each trigonometric function behave? So will it increase or decrease? Okay, because if you are now through with the study of trigonometry, as soon as you see an angle, you should know what will be the variation in its value. Will it increase or decrease? Okay, and the next topic will be the proper signs of the different trigonometric functions, okay, in each of the 4 quadrants. First quadrant, second quadrant, third quadrant, and fourth quadrant. So without using any calculator, if you are given an angle from 0 to 360 degrees, and the problem is asking you what will be the proper sign of that trigonometric function, okay, where it will be located, at least you should know what will be the proper sign without using a calculator. Okay, let's proceed. For the values, we assume that the different functions will try to increase from 0 to 360 degrees. Okay? This will be a complete cycle. Complete cycle meaning one complete revolution. If we are given an angle in the first quadrant, second quadrant, third or fourth quadrant, so the maximum variation of the value is actually from 0 to 360 degrees. Okay, let's try to bring out the proper sign of each of the functions for each quadrant. Oh, no, it's not the signs. Sorry for that one, for the values. For the different function, will it increase or decrease? Okay. For a sine function, if it increases in value from 0 to 360, okay, how the value of sine function will behave? It should increase. It should increase. Like a special case, sine of 0 will be 0. So as soon as we increase the angle, like a 1 degree, if we try to take the sine value of this one, it will increase 0.017, and it will go to maybe 8 degrees. We'll take the sine of that 0.139 already. So the variations of this, as you increase the value from 0 going up, the variations of the value for a sine function will increase. Okay? It will start with 0, then it will go up. It will increase. So this is increase. For a cosine function, it's a different story. Because for a cosine function, if we start with 0, the cosine of 0 is actually equal to 1. Cosine of 0 is 1. If you try to punch 0 here, we'll take the cosine, the value of 1. So meaning to say, for a cosine function, okay, at 0, the value is 1. But as soon as we increase the value, supposing we put it at 25 degrees, and we'll take the cosine of this one. The value now is 0.906. Okay, 0.906. Supposing it's 60 degrees, we'll take the cosine of that one. It is now 0.5. Okay, so it starts from 1, it goes to 0.9, it goes to 0.5. So as we approach the value 360, okay, the variations in the value of the cosine value function is actually will decrease. Okay, you got it? For a sine function, it will increase as it moves from 0 to 360. For a cosine value function, it starts with 0 degree, and as soon as it increases from 0 to 360, whether we like it or not, the value should decrease. And the highest value of the cosine is actually 1. Okay? And the lowest value for a sine function is actually 0. That's why for a sine function, it will start from 0 going up. And for a cosine function, it will start from 1, then it goes down. Okay? It will approach the value 0. Okay, how about the tangent function? For the tangent function, you don't have to look at the, what do you call this? No. You don't have to look at the given figure. We are still on the value. What is tangent? Tangent is actually sine over cosine, right? So an increased value over a decreased value, if the denominator is less than the numerator, okay, denominator is less, cosine is the denominator, it will increase. So for a tangent function, it will increase. Because the ratio of an increasing value over a decreasing value, it should be an increasing value. Okay? The denominator is decreasing, so what will come out if we try to divide this will be increase. For a cotangent, okay, cotangent is the reciprocal of tangent, right? And cotangent is actually 1 over tangent. This is 1 over increase over decrease. So this will now become a decrease over increase. The increased value is at the bottom, the bigger value is at the bottom. On the numerator, it's the lesser value. So as we divide it, what will come out will be decreasing value for a cotangent. Okay? For the cosecant, cosecant is the reciprocal of sine, right? So this is 1 over sine. This is 1 over, what is sine? Increasing, right? So this is 1 over increasing. 1 divided by an increasing value, what will come out? It will decrease. Okay? For the secant is the reciprocal of cosine, and secant should be 1 over cosine. So this is 1 over, what is cosine? Decreasing, right? So 1 over decreased value. 1, we stay as 1, but as soon as we decrease this one, the ratio should increase. Okay? You don't have to memorize the last 4, 1, 2, 3, 4. The basic thing here is at least you know the variation in the value of sine. For sine, it will increase. Okay? Okay? For the cosine, it will decrease. And for the other ones, by using the standard relation, we could actually determine if it will increase, decrease, or increase by using these ratios here. Because you know the relation of tangent with respect to sine and cosine. Right? Increase over decrease, it will increase. Cotangent, 1 over increase, it will decrease. Cosecant, the reciprocal of sine. This is increase, so this should decrease. And for secant, it will be cosine. This is decrease, so it will increase. They are reciprocals. So the basic thing here is at least we know what will be the variation in the value of sine value function and cosine function. This is very important, okay? So when you're solving problem, at least you now know if the values you have substituted to your equations are correct or not, right? That's the relevance of this one here. Okay, the next one. How do we know the proper signs of the different trigonometric functions. Many of us don't actually grasp the concept on this one. So I will now be presenting the proper way on how to, what they call this, remember the proper signs of the 6 trigonometric functions for each quadrant. 1, 2, 3, and 4. It's an easy one. Okay, let's continue. If a given angle is in the first quadrant, our reference is 0, right? And angles here are measured counterclockwise to be positive. So I will erase this one. So this is the vector here, and its reference angle with respect to 0 is angle theta. So if the vector is actually on the first quadrant, the real part is actually plus, and the imaginary part is plus. So I put here, this is a plus value, this is a plus value. Of course, the hypotenuse will be a plus value. There is no such thing as a negative hypotenuse. And if we now try to determine the sign of the different 6 functions here, just what you call this, implement your knowledge on the so-called definition of trigonometric function. Okay, let us start with sign. If we try to determine the sign of an angle that falls on the first quadrant, sine is actually considering this angle, this is opposite, adjacent, this is hypotenuse. Sine is actually opposite over hypotenuse, so it should be plus over a plus. Plus over a plus will be plus. So meaning to say, if you are given an angle that falls on the first quadrant, if you take the sine function, the sine is always a positive thing. Okay? For the cosine, it's the same. Cosine is adjacent over hypotenuse. Considering this angle theta here, adjacent over hypotenuse, a plus over a plus. So the sign of the cosine function will still be plus if it falls under the first quadrant. As easy as that one. For the tangent, okay, we now know the sine and cosine. So apply your knowledge of the definition of tangent. Tangent is actually sine over cosine, right? And what is the sign of sine? It is plus. And what is the sign of cosine? It is plus. So a plus and a plus will still be plus. Meaning to say, if you are given an angle that falls on the first quadrant, the sign of the tangent function should also be plus. Okay? The remaining 3 will all be plus. Okay? Because for a cosecant, just take the reciprocal of sine. So that will be 1 over the sine of sine is a plus, right? So 1 over a plus is plus for a cosecant. For a secant, it will be 1 over cosine. Cosine is plus, right? So this is 1 over plus. A 1 over plus is still a plus. For a cotangent, it's the reciprocal of tangent. So this will be 1. Tangent is plus, right? 1 over plus. And the sine will still be plus. So under quadrant number 1, the sign of all the functions are all plus. Okay? It is plus. For the second quadrant, if the angle of the vector now is greater than 90 degrees, it falls under quadrant number 2. Angle theta is greater than 90 degrees. This is where many students, okay, made a mistake on the proper signs if an angle falls on the second quadrant. Okay, let's try to bring out the proper sign. If this is the vector, its angle with respect to 0 degrees, this angle theta here, and this angle theta is 90 degrees. Okay? If we try to take the horizontal and vertical component of this vector here, this one goes to the left, so the sign is minus. Okay? This one goes up, so this is a plus. Right? The hypotenuse will still be plus. Okay? Let's try to bring out the proper sign of the different functions. For a sine function will be opposite, okay, over hypotenuse. That's the definition of sine, right? Because considering this angle here, which is actually 180 degrees minus theta, right? this is the opposite angle. So if we try to take the sine, it will be this side here over this. It's a plus over a plus, so it's a plus. It's a plus. I will try to give you an example. Supposing the angle is 120 degrees, and if you try to take the sine value, the value is positive 0.866. Okay? So the significance of this plus sign here is this one. Okay? It is this. I know that if I will try to take the sine of an angle that falls on the second quadrant, the proper sign should be plus. And you could verify this using your calculator. And the verification by using the figure will be this. A plus over a plus will be a plus. For a cosine, this will be the adjacent side, right? So it will be the ratio of this side here over this. A negative over a positive. The horizontal part is actually negative. Okay? So this should be a minus over a plus. So for a cosine function, the sign of it will be a minus. It is a minus. Right? So how could we prove this one? Like 120 measure counterclockwise. If you try to take the cosine value of this, the value here is negative 0.5. And the significance of this negative here is actually this one. Okay, you got it? Oh. For the tangent, it's an easy job now because you know the sine on cosine. Just bring out the definition. Tangent is sine over cosine. Sine is actually plus. Cosine is actually minus. A plus over a minus will be a minus. So, meaning to say, if you are given an angle and it falls under the second quadrant, the proper sign should be minus. Okay, 120 degrees. It falls under the second quadrant. We will take the tangent value of this one. The value is negative 1.732. And the significance of this negative here, it is actually this. Okay? For the next remaining function, it's an easy now. You know sine, cosine, and tangent, just take reciprocals. So for cosecant, it is the reciprocal of sine. So this is 1 over a plus, it will be a plus. Right? So actually this one could be derived from the sine value. For the secant, it is the reciprocal of cosine. And cosine in the second quadrant is actually minus. So this is 1 over a minus. 1 over a minus is still a minus. And for cotangent, it's the reciprocal of tangent. So this is tangent is minus, right? So this is 1 over minus. So this will be minus. Right? So the last three, there's no problem, but as long as you are correct on the sine, cosine, and tangent, you could derive the last three. The most important thing here, you know how to draw your vector diagram. Okay, so you could determine which is minus or which is plus. Next one. Am I still on camera? Last one. It's the third one. Third one. It falls under the third quadrant. First quadrant, second quadrant, third quadrant. This should be the vector. The angle theta with reference to 0 is this. Theta is actually greater than 180. Right? Greater than 180. 180 is this straight line here. Okay? If we try to bring out the vertical and horizontal component of this vector here, okay? This what you call this horizontal part is minus. It goes to the left. And the vertical part is actually going downward. So this is still minus. Of course, the hypotenuse will be plus. Right? So if you try to take the different signs of the different functions, we start with sine. Okay? Sine will be opposite. Okay? Over hypotenuse. So that will be minus over a plus. A minus over a plus will be minus. Okay? I will try to bring out the what you call this validity of that one. We will place 210 degrees. 210 degrees is more than 180, right? If we try to take the sine value of this, sine. The value is negative 0.5, and that negative here refers to this. Right? So without you even using a calculator, if you could try to figure out, you will know what will be the proper sign of the different functions. For the cosine, what is cosine? Cosine is adjacent over hypotenuse. The adjacent is minus, it goes to the left. The hypotenuse is always a plus, so this will be a minus over a plus, and it will be minus. So meaning to say, if you try to punch an angle that falls under the third quadrant and you try to take the value of the cosine function, okay, the value is still a negative value, negative 0.866. So the significance of that negative sign here is this one. Right? Since we now know the value of sine and cosine, we just apply our knowledge of the definition of the different functions, so we could derive the last four. Tangent is sine over cosine, right? So it should be a minus over a minus, a minus over a minus, okay? Fundamental operations, algebra, a plus. Okay, let's try to bring out 210 degrees. It falls under the third quadrant. We will take the tangent function of that one. It's a plus. 0.57735. It's a plus. So this is correct. Right? And that plus emanates from this. A ratio of a minus over a minus, it's a plus. Okay? For the last three, I will just take reciprocals. For cosecant, it's the reciprocal of sine. This is 1 over minus, it is minus. 1 over a minus is a minus. For secant, it is 1 over cosine. And cosine is minus, right? So 1 over a minus, it's still a minus. For cotangent, it's the reciprocal of tangent. So this is 1 over a plus. So it will be a plus. You don't have to memorize this one, okay? Just start with the definition of sine and cosine, and you could derive the last four. Okay? And you know the definition of a sine, right? Opposite over hypotenuse. Cosine is adjacent over hypotenuse. You just start from that one, you could derive the last four. Okay, the last part. If the given vector is actually or falls under the fourth quadrant, meaning fourth quadrant is greater than theta will be greater than 270. Theta, because 3 complete revolutions is, 3 complete quarters will be 270. 90 times 3 will be 270. So theta is actually greater than 270 degrees, and it should fall under the fourth quadrant. Okay, this will be the vector. The horizontal part will be this one. It goes to the left. Alright, so its sign will be plus. And the vertical component, it's downward. So the sign of it will be minus. Of course, the hypotenuse will be plus. Okay, let's try to take the sign of the sine function. Sine will be opposite, okay, over hypotenuse. So a minus over a plus. So this is a minus over a plus. A minus over a plus is a minus. Okay, I will try to give you an example problem. If the given angle is greater than 270, 300. We'll take the sign of this, sign value. It's a negative 0.866. So that negative sign refers to this. How about the cosine value? For the cosine, it will be the ratio of the adjacent side over hypotenuse. It's a plus over a plus. A plus over a plus will be a plus. So meaning to say, if the given angle or vector falls under the fourth quadrant, if we try to take the cosine value, 300, we'll take the cosine, it will be plus 0.5. So that plus here is this. Okay? We are done with the sine and cosine. We are correct with this. So of course, the next four will be correct. Tangent will be sine over cosine. A minus over a plus. A minus over a plus will be a minus. So the sign of the tangent function, if the angle falls on the fourth quadrant, it should be minus. Okay? Cosecant, just take reciprocals. Cosecant is the reciprocal of sine, so this is 1 over minus. 1 over minus will be minus. Okay, for the second, it should be 1 over cosine, 1 over plus. Cosine is plus, right? A 1 over plus is a plus. And for the cotangent, it's the reciprocal of tangent. So this should be 1 over minus, and this should be minus. Okay? Okay, that's it, guys. I hope that you will absorb this concept on how to memorize the variations and the values of the 6 functions values and the proper signs of the 6 trigonometric functions in each quadrant. First quadrant, second quadrant, third quadrant, and fourth quadrant. If you try to memorize this one, you will not get lost in the study of trigonometry. Okay, good evening from Los Angeles. Professor David Yedels.